So our last speaker of this session with a ratings theme is Todd Graves, and he's in the Statistical Sciences group at Los Alamos National Laboratory. He has interests in materials science, reliability, and Bayesian computation, and is going to talk today about Rush.
Cool. And this is the microphone, I guess. All right, so this is a talk about rating college football teams. College football is interesting because automatic ratings of teams play this official role in, not a very large role, but an official role in in who wins the national championship. And this enormous cottage industry in amateur methods of rating college football teams has sprung up. So there are a huge number of those, and I'll hope to convince you that that the one we've come up with is different in an important way. So thanks to my co-authors, Carrie Myers, who's here, and Earl Lawrence and Shane Reese, who are not here. So just to give you a little bit of background and history, college football has always been pretty unusual in how it's determined its national champion. Up to 1998, there was a regular season, and then some teams were selected to go to bowl games, and then after that, a poll of sports writers and a poll of coaches each had their own poll, which named a national champion. So there was no effort to pair the best teams against each other in the bowl games, generally speaking, and so in a pretty rapid fire, in 3 times in 7 years, we had this situation where 2 teams in the same year just ran through their competition and were very legitimate national championship contenders and did not end up playing each other, and so there was some dispute about who should be the national champion at the end of that. So under this situation, there was a lot of complaints about how college football was the only major sport that had so much question about who the national champion was. So as immediately after the third of these controversies, this thing called the Bowl Championship Series was formed, and they replaced no playoff system with a playoff system involving exactly 2 teams, and they selected the 2 teams to play in that game based on our friends the polls, and also of interest to this audience, they added these set of things which they called computer rankings, which were automatic statistical-based systems, statistical in various degrees, that looked at that season's game results and automatically spit out some ranking of the teams. And so there was still lots of agitation about this, still lots of complaints, but now it was about non-football people affecting who plays in the postseason tournament. And although this was a playoff system, people in general wanted a larger one, and some particular reasons for that are frequently there are either more or fewer than 2 teams that belong in the national championship game, and in a lot of people's opinions, this reached an extreme in 2003, where the national championship game was between Louisiana State and Oklahoma. And the sports writers poll had a 3rd team, Southern California, as their number 1 team. So this was thought to be an outrage in many quarters. Hal Stern, in his paper in the J class, I guess it is, summarized a lot of the problems with the BCS very well, and in fact recommended that people like us not participate in it because, for example, the current role of these computer rankings in the ratings is actually quite small, and in his view it serves only to add this veneer of objectivity to the polls, which are really determining things. Also, the computer rankings are not allowed to use all the information in the data. They in fact have to ignore the margin of victory and just look at who won and lost each game, and perhaps the most important objection is that by participating in this, you're participating in this system, which is extremely unpopular among fans, and preventing people from seeing legitimate national champion that they want. So this is the universe that we're trying to step into here. So what are our goals? We're trying to provide something which could be used in an official capacity to select teams for either the current playoff system or a larger playoff system. So in principle, each team would start from the same position, and then their estimated ability would be updated based on what happens in the season. Maybe the most difficult thing to do here is to compare undefeated teams from a weak conference with teams which maybe have one loss from a stronger conference. So to do that, there's the information to compare teams in a college football season is really sparse because teams play almost all their games against teams in the same league, and then frequently play teams that are as weak as possible in the rest of their games. So the top teams frequently don't play each other or anybody that would help us compare them to their rivals. So and also there's always been a concern with having an automatic computer-based rating system, which if the teams knew what you were doing, would know that it would be advantageous to pile on all sorts of irrelevant touchdowns at the end of the game just to make you look better to one of these rating systems. So we want to avoid that as well. So I guess here's one of the families of well-known methods to rate college football teams or other teams, or other individuals for that matter. So one thing you can do is ignore the final score, ignore the final score, and just look at who wins and loses. And this leads to a pretty large family of rating techniques, and they're pretty simply based on each team having one parameter to describe them. And if you want to know what the probability of one team beating another team is, it's just a simple fraction like this. A potential problem with this is you're throwing out a lot of information. You treat complete mismatches the same as overtime games, and at least in my experience, this has a tendency to give fairly large ratings to teams that go undefeated against weak schedules. So another big family of rating systems looks at the margin of victory in the end of the game, the score of the visiting team minus the score of the home team at the end of the game. And so sort of the most obvious way to do this is to do a least squares fit of the visitor scores minus the home scores on a set of dummy variables which identify who the visiting team is and who the home team is. So a potential problem with this is that it treats losing by 1 point as about the same as winning by 1 point. And that may be fine from a prediction point of view, but so people may potentially not understand that that's what's going on, and see that two teams are in some order in your rankings where the bottom team beat the team above them, and think and in fact this probably has contributed to some of the unpopular national championship game selections in the past. So what do we do instead? So instead of looking at the final score, well, we do look at the final score, but we in fact look at the score of a game at every point in time. And how do we do this specifically? If the score of a game is such that one team has a huge lead relative to how much time is left, scores that happen after that are severely down-weighted. So we'll see how that works here. So here's an example of data that we might have from one particular game. This is one of the most important games of the 2010 season. One of the last hurdles that Auburn had to clear before playing in the national championship game was their game against their arch rival Alabama, who was also the defending national champion at the time. And so they had this game and then the SEC championship game coming up. And they in fact fell behind 24-0 in the first half before rallying to make a comeback, and won by 1 point. And therefore cemented themselves in this storybook season that they were having. So now I'll depict how our model evaluates these two teams as time goes on in this game. So what we're looking at here is we have on the x-axis we have the amount of time that's gone by so far in the game, and we're looking at we're trying to estimate the Auburn's ability minus Alabama's ability. So, and here in this black piecewise linear thing is the maximum likelihood estimate as a function of time, and we've also got likelihood-based confidence intervals as a function of time. So, for example, here when it was 21 or 24 to nothing in favor of Alabama, we were quite confident at the 95% level that Alabama was actually the better team, at least in Tuscaloosa where this game was played. But as the game went on, Auburn came back and made things look closer, and then in fact won. And at the end of the game, our estimate is that Auburn is a little bit better than Alabama at that point in the game. Okay, so that seems pretty reasonable for a game like this, but what we were really trying to accomplish is something that's depicted here. So I'm I'm originally from Oregon, and now I live in New Mexico. So that was an interesting game. Oregon was one of the best teams in the nation last year, and New Mexico was one of the worst. And this game went exactly it went roughly how you would expect. And as you can see, this really wasn't an example of Oregon running up the score. They only scored 13 in the second half of this game. But the key point from the point of view of our model is that our estimate of the relative abilities of these two teams didn't change visibly at all after it was 35-0, and didn't change too much after it was 28-0. So this remaining 37 or 44 points that Oregon put on after this point didn't affect the two ratings of the teams really at all, and that's one of the things we were trying to accomplish. Okay, so our third example here, before I tell you what we actually did, is I'm going to show you a family of hypothetical games which all were assumed to end 28-0. The visiting team got 4 7-point touchdowns at evenly spaced intervals. And our first example is they scored with 2, 4, 6, and 8 minutes gone in the game, and then let's see, on the x-axis here, we're looking at how many minutes it took them to score each of their 4 touchdowns. So over here on the far right, we've got an example of where they essentially score at the end of each quarter, and then our conclusion there is so our confidence intervals even include 0. So it's not even as far as we say, this can even happen with between two teams that are equally good, or even the team that wins can be a little bit worse than the team that loses. So we've got a huge range of what can possibly happen here of games that end with the exact same final score. And so if the 4 scores happen at 2, 4, 6, and 8 minutes, that's pretty much as extreme as any game we saw last year. And it goes from there to not even being clear that the winning team was necessarily better. All right, so what do we do to get to this point? So here's some of our notation. We've got each team has a parameter called theta, which is an estimate of its ability. There's assumed to be a common home field advantage that every team has. Each game has a different expected number of scores per unit time, and what that is for a given game is it's a sum of terms corresponding to each of the two teams. So the tau for a given team is a combination of how good your offense is, how bad your defense is, and just how quickly you play. And then we look at this. We look at the way the score can change. For a given scoring play, it can change in any of these ways. So we treat a touchdown and a conversion as being the same. And the surprising one here is in college football, you can actually get a change to the score margin of 4 points, which is where you score a touchdown and then the other team intercepts your pass or blocks your kick and returns it for 2 points of their own. And so we treat that as a single score, and that changes the margin by 4 points. That happens in about one out of every 700 scoring plays. So these are the down here. These are the fractions of total scores that are each of these types. 7-point touchdowns are by far the most common. It will surprise no one to hear. All right, how do we glue these things together in our rating system? In each game, we can only estimate the difference between the abilities of the two teams, including the home field advantage. And the object we're trying to model is this stochastic process, which is the score margin as a function of time. And so the key element in what we do here is this function. So think about what is the probability that the visiting team wins. That's what this is. Given that, given that at time t the score margin is equal to m, given that they're, say, ahead by 17 points with 25 minutes gone in the game or something like that. Now, how does that probability change as a result of a given score? If at time t there's the visiting team gets an additional touchdown, or the home team gets an additional safety or something like that. So now that we've defined this object, this is exactly what we want to relate to this parameter which governs the difference between the abilities of the two teams. And we do it like this. We use point process arguments. So given that the margin at time t is equal to m, what's the probability that you're going to get a new score of each of the possible types in the next small interval of time? And that's, the overall rate of scores times the length of that little interval times the overall probability that it's going to be a score of a various type, and then adjust that by this exponential with team's ability in it, and with this change in the probability that the visiting team would win. So, all right, so that leads to a complicated likelihood function, and we do a Bayesian analysis of that, estimating all these lambda parameters and all the population level parameters and all the team abilities. And we end up with something which is not terribly easy to compute, but it does have a few. So if your goal is transparency and getting the participants to be able to calculate their own ratings, that is definitely not going to happen here. But a few things do happen that help us calculate things. So we want to calculate this probability that the visiting team wins, given that the two teams are evenly matched, and that's based the score. And when that's true, when they are evenly matched, scores occur according to a homogeneous Poisson process, and the probabilities of the various types of scores are these pi's, which are fixed and known, and a whole bunch of things can be pre-computed, and so this is actually somewhat tractable. And we did the MCMC computations in this software called YADIS, which I wrote to analyze reliability a long time ago, but it can be used for other things too. Okay, so what are some properties of how we do here? So we can use our model to generate a predictive distribution for what the score margin is going to be in each game, and then we can look to see when the game is actually played what quantile the observed score margin appears in relative to the predictive distribution. And so various things you could see in plots like this are what we get here is the visiting teams are not doing quite as well as we expected them to. And this is not surprising, because at the beginning of the season you have all these games between pretty strong teams at home scheduling games against weak teams on the road. So this is before we know which teams are the good teams and which teams are the bad teams. I don't think I said that a given plot here is we take the data up through, say, week 10 and then predict all the results in week 11. So ideally here we would be these quantiles we would be getting a sample from the uniform 0-1 distribution, and we're plotting them against. We're doing essentially a QQ plot here, And by the time things settle down, we do actually get these observed quantiles landing on the x equals y line, which is where they belong. We did have a sort of a strange week here in one of the last weeks of the season, and there were just an unusual number of beatdowns applied by the visiting team, especially in the playoffs of the FCS of Division I AA. So let's see. So I guess one of the things I sort of expected and feared to see was that our predictions would be. I expected our predictions to be somewhat to have more noise in them than the actual results did. And if that was true, you would see something that looked like a sigmoid, like an S function. And really we don't get that. And so that's a good indication of us being well calibrated. Let's see. How am I doing for time here? Okay, should be able to do that. So we also compared our predictions on a weekly basis to our method, which is called Rush, to the Bradley-Terry method, which just looks at the final, or just looks at who won, and this least squares based margin of victory model. And so, as a function of week. And so what you can see is, and this is confirmed by a sign test of which ones we got right and Bradley-Terry got wrong versus the other way around, is that we are actually doing better than this Bradley-Terry method, a Bayesian version of that, and we're doing about equally well compared to the margin of victory model. So it's not entirely clear whether we should be beating the margin of victory model or not. We're using more information than that model is, but the way we're using it is to look at some of the information and decide to ignore the remaining information. So it's not clear which of these is expected to be better. And at any rate, we would need more data than we've actually looked at to this point. Okay, so let's talk about some of the specific teams here in 2010. The national championship game, it was there was relatively little grousing about who played in the national championship game in 2010. I've already alluded to Auburn, who won all their games in the league from which the national champion has come in every year of the last 5 years, and then also Oregon, who was champions of another pretty strong league, and then they won. They didn't have any other 72-0 games, but they did beat teams by sort of large amounts quite often. We mentioned that we would like to compare teams like this to teams that were in conferences that are not quite as strong, but where they've made very dominant performances in those leagues. So there are essentially two big surprises in our results. So Boise State played, as every year for the last several has had a season much like this, with either no losses or one loss. But and last year they actually lost once, and even so, our method was more impressed with them than with anybody else. Sort of the consensus national champions, who everybody thought should be in the national championship game, was Auburn, and they're down here at number 7, not even above the team that they beat that's in their same league. So let's see another view of this. Here's a set of box plots of the posterior distributions. So there's really a lot of overlap among the distributions here, but Boise State is kind of a clear leader. So, all right. So how can this be? How can the national champions be rated so low and Boise State be so high? Well, we've already looked at this game that Auburn won by 1 point after trailing 24-0. They also won a bunch of other close games, and those teams were not always against real world beaters. It took them overtime to beat a fairly decent Clemson team, and they won on the game's last play against a fairly mediocre Kentucky team. So I guess from a sports writer's point of view, Auburn was a great story, and they won all their games in exciting fashion, and therefore they were deserving national champions. I would certainly agree that they were deserving national champions, but I'd also point out that the data suggests that they were extremely lucky, and we simulated 100 seasons from our model, and it was about a 3% chance that they would be undefeated, and it was actually almost 50% that they would lose 3 or more games and not be in the national championship discussion at all. So the other sort of surprising team was Boise State, even with a loss in a mediocre conference. This is what the score margins were in their halftime games. They had in their season opener against Virginia Tech, they were ahead by 6. Then they were pretty much ahead by 2 touchdowns in all the rest of their games. Even the game they eventually lost to Nevada, they were ahead by 17 at halftime of that game. So when we simulate seasons for them, we think it was about a 50% chance that they should have gone undefeated, and actually doing worse than they did was extremely unlikely. Or well, it was a 10%. It was about 10% that they would do worse than they actually did. So I'll also point out that we've run this for the 3 seasons before then, and it isn't an every year occurrence that we have some surprisingly high rating for a mid-major team like Boise State. So in both of these years, there were I guess other at least in this year, in 2007, there was the only undefeated team at the end of the regular season was Hawaii, and that was a completely upside down season in a lot of ways. And so they ended up playing in a BCS bowl game and losing badly. But so a method like this, it's interesting to see what a method like this would do for them. And at the end of the season, they were not even in the top 40 of the teams we rated, despite being the only undefeated team. They did play a quite weak schedule and were moderately impressive against it. So a little more detail about what the various rating systems this year. Actually, the margin of victory based model rates Boise State and Auburn similarly to what we do. But the Bradley Terry type model gives you some comfortable results that at least people are comfortable having that in the formula, which decides who plays in the national championship. I also listed Michigan State as an example of a team that margin of victory hated. They got totally clobbered in both of their losses, but they did have 11 wins against a schedule of some strength, and so being 44th in the nation is probably too low, and we end up with them in 16th place. Let's see, and that's all I have, unless you have some questions.
Take a couple of questions. You have any? Hello?
I really like this method. One question I had, wouldn't this, like if this method was, let's say, used to rank teams for the BCS,
Right.
wouldn't you be providing incentives for teams to try to put games away early?
Yes, we're not providing incentives for teams to score a lot of points in the fourth quarter, but it has been pointed out that if you win the toss, you should probably elect to receive and try to score on your first possession. So that's a potential grounds for criticism. But I guess I feel like if you're able to put teams away early, both teams are presumably playing as well, or they're playing their first strings. They're playing as well as they can at that point, and so I'm a little more comfortable with giving teams credit for that.
In case like your strategy is more of like a rope-a-dope type thing, where it's like, oh, well,
Yeah.
then in the end, this would theoretically penalize that team a little bit, right?
Right, absolutely. If you're trying to wear out the other team and then win in the fourth quarter, you're not going to be adequate or accurately rated in that sense. Yeah, that's a good point. So.
With the fact that pace of an offense isn't necessarily consistent throughout the course of the game, like obviously at the end of the game or half, or throwing the ball out more, has a significant effect on these.
That would be a good thing to look into, because of course you're right. Teams are stopping the clock intentionally and calling timeouts and things like that. And we're ignoring that. We're ignoring a few other things, like the fact that you kick off after scoring. We're treating it as if the ball starts at a random position, not with a random possession after that point. But yes, your suggestion is a good thing to think about too.
One question, and then don't leave. We need to poll. We have one question for the audience afterwards, but let's take this one.
Yeah, it's on a slightly similar though, actually, because you look at using any of the data to try to kind of eliminate noise from kind of 16 games in a short season. Perhaps, you know, few turnovers here and there can be absolutely crucial in there. In a score difference, margin of victory, say. Is there any scope to sort of use additional data to help improve the rating system?
So I think. Let's see. Let me try. I'm not sure people heard you, so I'll just try to say some things about what. Try to repeat a little bit about what you said. And maybe you can tell me whether this is fair or not. So is it possible to look at how much the influence of specific plays, which might have been quite random, how those affected the ratings, and then is it possible to look at even greater detail? Look at say field position and non-scoring plays also. So for your first question, I think it would be interesting to look at the impact of specific plays. We haven't done that yet, but can we change one play and move, say, Ohio State up to number 1 or something like that? And for your second question, I think it would be very interesting to look at even more detail. Don't necessarily have an idea how to do that yet, but that could be. You'd need a few. I guess if you change the number of types of plays from 12 to a lot more, it would. Yeah, you'd probably need to think about that a little bit and use some aggressive hierarchical modeling. And yes, and that's true too. I suppose you could try to rate individual players, for example, to get back to some of the talks we had this morning, I guess. So.
All right. Our poll question is: how many of you are planning to go to the tavern at the end of the day?
Yeah, let me put it this way. Raise your hand if you're more likely than less likely to go to tavern in the square tonight. Just want to get a rough idea. That looks like about 40 or so. Okay. All right, thank you. All right, so yeah,
go ahead. What do you want to say about
so we're going to be now taking our lunch break. There's lunch outside, sandwiches, drinks, dessert, and we'll reconvene at 2 o'clock with J.P. Ricciardi starting off.